In our last couple of videos, we looked at the concept of a relation and a function. And we saw that if we have a graph, the points on the graph, all of the infinitely many ordered pairs on the graph are values of x and y that if I were to plug them into the function would make the function a true statement. What we're going to look at in this video is the concepts of increasing, decreasing, and constant, and we're also going to review our the idea of domain and range. And we're going to learn a little bit more about interval notation, which just means the way of writing an interval. So let's say that we have a graph that looks like this, and I'm not really going to define the graph as f of x equals or whatever. We're just going to look at it visually from the picture. So just going out here to 6 and negative 6. 1, 2, 3, 4, 5. And then down to negative 6. And I'm just making this function up. But let's say that this function looks something like this, that on this portion of the graph, it just goes straight across. And then at x equals 3, it goes up. And over here, at x equals negative 2, it is coming down in this direction. And these two arrows here on the left and the right just means that the graph continues to go back that direction and back to the right. So what we're going to look at here is we want to know, where is this graph increasing, decreasing, and constant? And when I use those terms, I'm always saying, where is y increasing as x moves from left to right? So we're always saying, as x is moving from left to right, what is y doing? If I'm looking at this piece of the graph over here on the left, as x is moving along the axis, in other words, for x equals 1, 2, 3, 4, 5, 6, as x equals negative 6, what is y? As x equals negative 5, what is y? As x equals negative 4, what is y? We're saying, what is y doing as x is going from left to right? And we see on this piece of the graph over here that y is going down. So that means that y is decreasing. So this arrow right here has nothing to do with the concept of increasing, decreasing. This arrow means that this graph continues on this direction forever. But when we're talking about increasing, decreasing, we're always moving from left to right on the x-axis. What is y doing? So we see y is decreasing here. So this function is decreasing, and it started out here at negative infinity. So it's decreasing from negative infinity. And we see, where does the behavior of the graph change? And it changes right here at x equals negative 3. So right here at this point, the graph is neither decreasing or constant. And we're going to see the next piece is constant, because the behavior is changing at x equals negative 3. So we do not include that boundary. We put a parenthesis. So for increasing, decreasing, and constant, you will always have parentheses on your boundaries, because it's not doing either type of behavior when it's changing over. Then let's look, as we continue from left to right, what is the graph doing for these values of x? And we see that y is staying the same. y is equal to -2 for all those values of x. So on the interval from -3 to x equals +3, the graph is constant. And then when x equals 3, as we continue for my values of x, what's happening to y? And we see that y is increasing. So from x equals 3 forever, the graph is increasing. Increasing, decreasing, and constant intervals are always x values. Always the x values for which the y is increasing, decreasing, or constant. If we look back at this graph, which is kind of a mess, we can see also our domain and our range. The domain is the x value for which the graph exists. So as we move from left to right and we go up and down, actually, you know what? I'm just going to go ahead and redraw the graph so we can kind of see a little better what's happening here. So I'm going to reproduce the same graph or a similar graph. It should be the same. We already saw that on this portion of the graph, y was decreasing. For this portion of the graph, y is constant. And for this portion of the graph, y is increasing. And we noted that with the x values. Now the domain literally means the x values for which the graph exists. So as I sweep from left to right, where am I crossing, touching the graph? And I see that I'm touching the graph forever, from -infinity to infinity. So my domain is -infinity to infinity. For my range, I am looking at for which values of y am I touching the graph. So as I sweep from -infinity up, not touching the graph, not touching the graph, not touching the graph, and I see right here, when x equals 2, I begin touching the graph, and then I continue to touch it everywhere from there on. So my range is -2, and I'm +2, and I'm including +2. So I have a bracket to infinity. So for decreasing, constant, increasing, and domain, all of those are x values only. The only one that I'm going to use the y values is the range.